So following on from the previous video, I was trying to explain to you why this is exactly the same as this. So we would create a simple scenario where this k here is 7. So we would create this simple scenario here where k is 7, and then look at a specific case where n equals 5. So where we've got x to the power of 5. So look at this simple scenario. So I'm trying to show you why this is exactly the same as this. So looking at it from this perspective, it will then give us this. Looking at it from this perspective will then give us this. Because when k, so remember, k is this, n is this. So when you put 7 into the k, it would be 7, 7, and then the next one will be 1 less, times 6, and then times 5, and then times 5, and then it's blah 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 blah, and then the last one will be, well, let's just reimagine this as being k minus n minus 1. So by you visualizing this rather than this is easier to understand what's going on, because this is 1 less than this. This is n minus 1. So remember, we are looking at it for the case where n equals 5. So this will be 5. So for the last term, it would be 7, because k is 7, and then you've got your take away, and then 1 notch lower than this, which will be 4, So this whole thing here will be 3. So the last term will be blah blah blah, and then the last term will be 3. So when k equals 7, this whole thing here will then be this. So now let's look at it. Let's look at this thing here, n factorial. So that's really 5 factorial. So looking at it from this perspective will then give us this. And then if you look at this here, these three will cancel out, leaving you with this divided by this. So now let's look at it from this perspective. So k factorial. So this is k factorial, which will be 7 factorial. So this thing here will be this. And then k minus n. So k minus n will be 7 take away 5. That will be 2. And then you've got your n factorial, which would be 5 factorial. So looking at it from this perspective, it will then give us this. So if you look at this here, 5 factorial here will cancel out with this. So looking at it from this perspective, it will then give you 7 times 6 over 2 factorial, which is the same as what was earlier, what was over here earlier. So over here was 7 times 6, and then you've got your 2 factorial. Okay, so looking at it from this perspective, it gave us this. Looking at it from this perspective, it then gave us this. These two are exactly the same. So it gives you an indication that they're the same. But let's look at it from another perspective. So let's imagine. So here, if you look at this here, it would be k factorial all the way down to here. So hang on, let's just look at it from this. Let's look at it like this. So this is your k here, and then k times 1 less, and so on up to. So imagine this to be k here. So this is it's like your 7 here, and imagine this as n here. This is like your 5 here. So if you look at this, it's 7 times 6 times 5 times 4. So up into k minus n minus 1. So you're factorizing the k up to this gap here. So up to this gap here. Badly explained, but let me try and explain this again. So this is k here. This is your n here. So this is your k. This is n here. You're factorizing k up to this gap here. So you're factorizing k 7 times up to this gap here. So this is your gap here. So because you've got n minus, you've got k minus n minus 1 here. So this thing here represents this gap here. And then if you look at this here, n factorial would be would be from here all the way to here. So hang on, let me start again here. So k, so imagine this is 7 and this is to be 1. So k factorial, but up to a certain point. So this is your n, this is your k here. So k factorial up to a certain point, or this gap here will be this. So it would be k factorial up to here, Okay, so this is your k factorial up to here, and then you divide it by n. So remember, n is here. So you're dividing by n factorial. That's all the way to the end. Badly explained. Let me have another go. So hang on, bear with me. K, and then imagine this to be 1. So this is your n here. This is your n here. So this is your k. This is your n here. So looking at this bit here is k factorial up to a certain point. It's k factorial up to a certain point. So it would be k factorial up to a certain point, roughly speaking, up to here. And then divided by n factorial. Divided by n factorial, well, n here factorial would be all the way to the end. So for the numerator, it would be k up to here, and then divided by something that goes all the way to the end. So the middle terms here would cancel out with each other. So the middle terms here would cancel out with each other, and then all that you're left with is this bit here, which is this bit here, divided by this bit here, divided by this bit here. I hope you're following this. If you it's badly explained, but I hope you're following this. And then let's look at it from this perspective. K factorial. So from looking at it from this perspective, remember k here, k factorial all the way to the end, and then you've got divided by. Remember, n is here, k is here. So looking at this, k factorial would be you factorialing it all the way to the end, and then n factorial would be here all the way to the end. So this is all the way to the end. This is all the way to the end. So all these terms here would cancel each other out. So all these terms here would cancel each other out. All these terms would cancel each other out. So this would cancel out with this. So everything here, which is this bit here, up to the 5, would cancel out with this. And then you're left with this thing here, which is 7 times 6, and then manually divided by 2 factorial. I hope you're following this. And one more attempt. So this is your k here, this is your n here. So k all the way to, so hang on. So this is k here, this is 1 here. So looking at this here, it would be k factorial up to a certain point. So remember, this is your n here. So that certain point here would be, roughly speaking, around here. So this thing here, k factorial, would be you factorialing it from here up to this point here. And then looking at this thing here would be n factorial all the way to the end. So n starts here. So this thing, so divided by this thing all the way to the end. So all the way to the end. Okay, so anything in between here would cancel each other out. Anything in between here would cancel each other out. So anything in between here would cancel each other out. So all that you're left with is this gap here, which is this bit here, divided by this gap here, which is this bit here. Now look at it from this perspective. Hang on. So k, this is your k here, this is your n here. So k factorial would be from here all the way to the end, and then n factorial would be here all the way to the end. So they would cancel each other out. So this thing here, which is this bit here, would cancel out with this thing here, which is this thing here. These would cancel each other out. These would cancel each other out. So all that you're left with is this thing. And then if you look at this thing here, that's your gap at the end. That's your gap earlier. That's your gap at the end. I hope you're following this. It's not a definitive explanation as to why this is exactly the same as this, but I hope you can visually see why it's just badly explained, but these two are the same. Okay. Oh, and something else. We still need to understand why we still need to understand what happens when this thing here goes beyond the 7. You see, the highest that we've gone up to is like 7, 7. So here you've got 7. You start with 7, 0, 7, 1, 7, 2, and so on, up to 7, 7. But don't forget, n goes to infinity. So what happens when this thing here goes beyond 7? What happens when it's 7, comma, I don't know, 13, or 7, 14, and what does it even mean when this thing here goes beyond the 7? So if you look at this here, hang on. If you look at this here, we've always gone up to k, and then k. We've always gone up to this. But what happens when this goes beyond k? Because n goes all the way to infinity. What happens when you have let's say 7 and then 28? What does this even mean in the context of this thing here? We still need to address that. Okay.